Hey, what's up, everybody? It's Ned Bellavance, Ned1313 on Twitter. Welcome to the Daily Check-In for July 30th, 2020. It's Thursday, and you know what that means. It's Thursday on the edge. And so we're going to be talking about an edge computing related topic today. And that topic, I didn't really have one this morning, and then I listened to an absolutely fantastic podcast. It was an episode of the latest Shiny podcast. It's Rob Hirschfeld and Steven Spector's podcast. They do a lot of edge-related stuff, and this was just a fantastic conversation with James, I hope I get his last name right, Urquhart. I think that's how you say it. And a blog post that he did that they expanded into an episode and went down a few different alleys. So I read the article, I actually read the blog post too, and it was just fascinating. So that's what I want to talk about today is that this edge data flow idea that that James was working his way through in the blog post and then in the episode, kind of figuring out how it would actually work in a real world. So that was super interesting. That's what I want to talk about today. The only housekeeping item I have is I am on vacation next week. Actually, my vacation was supposed to start today. If you happen to listen to yesterday's, you'll know that my trip to Cape Cod was canceled, so I'm not on my way to Cape Cod at the moment. So I am going to do my regular posts for this week, and then next week I'm taking the whole week off. So I know you'll miss me. I know it'll be a long week, but I'm sure you can get through it, and then I will be back, doing my thing the following week, August 10th. So just so you know, that's why there's going to be a little gap there. I haven't gone away. I'm taking a much needed break from a bunch of things. Anyhow, so that's what I'm doing. I want to check in with you. How you doing? It's Thursday. Thursdays are they're about the edge. Thursdays also Thors Day. I don't know if you knew that. That's an interesting little thing to note is that a lot of our days of the week in English, at least, are named after, well, Viking gods. Oddly enough, Thors Day. Wednesday is Odin's Day. Anyway, so I'm probably getting way off tangent, but I hope you're doing well. I hope that Thursday's treating you okay and you're looking forward to Friday and whatever fun you might have planned for the weekend. All right, so let's talk about this idea that James came up with and the conversation he had with Rob. So I'll include links in the discussion, in the description for both the blog post and the podcast. And then there's also a book that sort of triggered some ideas for James. It's a book by Jeffrey West called Scale: The Universal Laws of Growth, Innovation, Sustainability, and the Pace of Life in Organisms, Cities, Economies, and Companies. So Jeffrey West works at the Santa Fe Institute, and they study a lot of these kind of just general topics, not specific to computing necessarily, but he really ties together how growth, innovation, and stability have common patterns throughout different instances. So organisms, how are we built as an organism, and how I won't say built, how we evolved to have the structure we have today and why it's pretty efficient at keeping us alive. And then he looked at cities and how cities are almost an organism of themselves. And while there is a central planning component to cities, there's also a lot of decentralized planning that happens along with it. And then looking over at economies again can be centralized or decentralized, but there's a lot of common patterns that repeat themselves. And those same common patterns show up in companies. Those same common patterns also show up in distributed systems and especially compute systems and their architecture. And a lot of it's driven by what the bottleneck is. What's the thing that is restrictive about a system that everything else needs to flow around, because at the moment that thing is fixed. So James dialed in on two things about computing that are pretty fixed and haven't changed significantly in the past, 5 to 10 years, 5 years, let's say. One he talked about was how long it takes to process a single transaction on a CPU. So while we've added the number of transistors that are in a CPU, and we've added the number of cores, and we've bumped the clock speed up a little bit, overall, the amount of time it takes to process a transaction has stayed pretty steady over the last 5 years. Minor incremental improvements and ways that we can make compute more dense, but that is one restriction, is how long it takes to process something. The other thing that he pointed out was the speed of light. That's not really a compute thing, that's just a physics thing. The speed of light only travels so fast, which means that we're bound by the latency between two objects that are physically separate. We can only send information between those two objects at the speed of light. And we don't even get close to the speed of light, really, because we're sending, even if we're using fiber optics or electric pulses, they are limited by the medium through which they travel. And so while the speed of light is a constant, the speed of information is not. And we've found ways to transmit more information, but we haven't really found a way to lower latencies below a particular point. It's sort of this, every little improvement we make makes it maybe a little incrementally faster, but overall, we had really incredible advancements initially, and then that has slowly dialed back as we reach the edge, if you'll pardon the pun, of what's actually physically possible. So those are two things that are restricting how compute can work. The other thing he talked about, and this is interesting, is the model that seems to happen is a trunk, branch, leaf kind of structure with a lot of these distributed systems. And if you think about that in the context of a tree, you've got the leaves that are bringing in sunlight and converting it to sugars and thriving within themselves, but then also sending that sugar back up the branch and down to the trunk. The trunk would kind of be that centralized component. Maybe we could call that a data center or a cloud. The branches are regional data centers or regional points, or could be extended because branches split multiple times into a gateway device. And then those leaves at the very end, those are your edge devices, whether they're consuming data that you're pushing down to them or they're pushing data up. So with that in mind, it was an interesting model to think about. The idea here is that as systems grow and become more complex, you're going to need more edge nodes because it's not efficient to send data or information. The flow of data can't all go back to the trunk. And it's pretty obvious when you think about the restrictions on latency and bandwidth, why it can't go back to the trunk and then be disseminated back down. Let's just take a simple example. Let's say that you've got 10 branches. Each branch has a theoretical maximum bandwidth between each other and also up to the trunk. Now, if all 10 of those branches are sending up to the trunk, they're going to hit a single or maybe two connections that are going back to that trunk, and they will saturate that long before they saturate their individual connections because those connections are aggregated at some point. Because of that aggregation, you reach a saturation point. Now, if the communication doesn't need to go up to the cloud or the central trunk, then it makes more sense to send that communication peer-to-peer. The problem we tend to run into is that we don't have standardized protocols for a lot of that peer-to-peer communication, especially in IoT. And that was a lot of the conversation around the podcast was we want to be able to stream data, but we don't have well-defined and universal protocols for creating a pub sub or a streaming and ingestion. Instead, it's kind of these fragmented protocols that are available on Azure and AWS, and they all implement this slightly differently. The CNCF has come up with a standard, but there needs to be more work on that to have a universal standard for streaming and consuming data. So that was one important thing that he talked about. The other thing that needs to be talked about is that data can be created at the edge and it can be consumed at the edge. And some of that needs to be actionable immediately. So if you think about a manufacturing line, decisions need to be made on the floor much faster than they can go up to a cloud and come back down. So some of the data needs to be processed locally. Some of the data can inform other systems that are not directly connected to the cloud. So there needs to be some sort of interconnection between those nodes that doesn't require going back up to a trunk. The metaphor that Rob came up with, and I really like this, is if you were buying groceries, you wouldn't take, and your grocery store is, 20 blocks away, you wouldn't go out to the interstate and up to a centralized hub and then come back down the interstate into the feeder roads and to the grocery store. You just drive straight to the grocery store because that's the thing you need. We need that level of like peer-to-peer communication amongst the points that are out on the edge to enable this style of communication. And I think we're going to get there eventually, but we need that distributed protocol that allows for streaming and collection and interoperability of different hardware stacks and different operating system stacks. The stuff that doesn't need to be processed immediately, is not latency sensitive, that's the stuff you send up to the cloud. If you want something to be held onto for long-term storage and analyzed and maybe combined with other streams of information, then that's the sort of thing that makes sense to send up to a cloud or a trunk or a centralized service. So that's kind of what I think we have going on here. And I think the conclusion of it is that edge is not just happening to a certain degree. Given our limitations, it's also inevitable. So that was the conclusion of it. And that certainly lines up with what I'm seeing as things grow. And we're talking like a 5 to 10 year timeline for a lot of this adaptation to happen, but it's certainly, you can see the markers are there and you can see that it's going to persist and grow over time. So that is what I wanted to talk about today. I'm curious what your thoughts are regarding the edge. I really recommend going and listening to the podcast episode and also listening or reading the blog post. I'm planning to get this scale book by Jeffrey West and give it a read as well, because it sounds really interesting. That's all I have for today. Tomorrow is Vault, so we're going to talk about Vault certification, and then I am off for a week. Until tomorrow, stay healthy and stay safe, everybody. Thank you.